Alright, this is the first question that we have. The question says, the turning point on the curve y equal to 3x squared minus 9x plus 12 is, what the question wants us to do is to determine the turning point and to determine if the point is a minimum or a maximum. Now, when does turning point occurs? Turning point occurs at the point where dy dx is equal to 0. That is where the gradient is 0. So we are going to look for dy dx of that function, or of the curve. Y is equal to 3x squared minus 9x plus 12. So dy dx is equal to, we'll differentiate this. 3x squared, differentiate it to get 6x. Differentiate minus 9x to get minus 9. Differentiate 2 to get 0. Okay, so since turning point occurs when dy dx is 0, and this is our dy dx, so I will make this one to be 0. That is 6x minus 9 is equal to what? 0. So I will solve. 6x is equal to 0 plus 9, which is 9. And divide both sides by 6. That means that x is equal to 9 over 6. And 9 over 6 is 1.5. So how do I now know if the function is maximum at 1.5 or minimum at 1.5? So from what I can see, my answer cannot be D, it can't be C, since both have negative. Now let's determine if it is a maximum or minimum. So there's a test we can use to determine maximum or minimum. We use the second derivative test. And that means I will have to differentiate this again. Now, for second derivative test, we have it that d squared y all over dx squared. If it is greater than 0, then it is a minimum point. But if d squared y all over dx squared is less than 0, it is a maximum point. So let me differentiate this function again, dy dx, to obtain d squared y over dx squared. Differentiate 6s, that's what? So d squared y over dx squared is equal to, differentiate 6x to obtain 6. Differentiate minus 9 to obtain 0. So our d squared y over dx squared is 6. And 6 is greater than 0. It means that the function is minimum at the point 1.5. So my answer is minimum at x equal to 1.5, option B. Question 2 says, find the area bounded by the curve y equal to x, in bracket 2 minus x, the x-axis, x equal to 0 and x equal to 2. And the options are given. So where is this question coming from? This question is coming from the application of integration, area bounded by a curve. Alright, so this is how to solve. We are given the function y is equal to x, in bracket 2 minus x, of which I want to expand to get 2 times x, 2x, minus x times x, minus x squared. So y is equal to 2x minus x squared. This is the function. Now, the area bounded by a curve, take note of this, is simply the integral of the function, in this case y, from the lower limit, which is 0, to the upper limit, which is 2, with respect to x. So this is it. My y here is equal to 2x minus x squared. So I have the integral from 0 to 2 of 2x minus x squared dx. Let's integrate. This is integration. So what we have now is this. Integrate 2x, it will be what? 2x, the power of x here is 1. So add 1 to it, it becomes 2. Then divide by this same 2. That is for integration. of 2x, it is 2x to the power of 1 plus 1 all over 1 plus 1, which is 2. Minus integrate x squared, it will now be x to the power of 2 plus 1, 3, all over the same 3, which is the 2 plus 1. We're integrating from 0 to 2. Alright, let's go ahead. 2 cancel 2, we are left with what? X squared minus x cubed all over 3, integrating from 0 to 2. So at this point, what I will do is to substitute the upper and lower limit. First of all, plug in 2 into the expression, minus plug in 0, and we'll evaluate. So this is what we have. Anywhere I see x, I'll put 2 first. So this is 2 to the power of 2 minus 2 to the power of 3 all over 3 minus, I will not put 0 now. Okay, 0 here is still 0, 0 here is 0. Alright, 2 to the power of 2 is 4. 2 to the power of 3 is 8, this is 8 over 3. Now, what is 4 minus 8 over 3? Let's break it down. 3 times 4 is 12, then minus 8 all over 3. What I just did is an alternative to LCM. Okay, 12 minus 8 is 4. And this is actually one whole number, 1 over 3. So I will add square unit to the result. This is the area bounded by the curve, y equal to x times 2 minus x, from x equal to 0 to x equal to 2. And I can see this option in my option C. That is 4 over 3. It's the same thing as this. I just broke it down. So option C is correct. Alright, this is question 3. We have to find dy dx if x squared y minus 5x is equal to 3. Now, what we can see here is an implicit relationship between x and y. This function is an implicit function in the sense that y is not the subject of the formula. Compare this to an expression like this. Y is equal to 5x plus 3. They are not the same. In this case, y is made the subject of the formula. Now here, y is not made. Both x and y, they are mixed up. So we call this explicit, we call this implicit. Now this is how to differentiate implicit functions. You can see this is a product, x squared y, multiplying each other. So I will use the product rule to evaluate the derivative of that very function. So the product rule says, write the first function, x squared times, differentiate this one. We wrote this first one, then differentiate this, which is, differentiate y is 1. So if I write 1, I will add dy dx to that 1. Plus, I'm still using the product rule now. I will now write this one, y times, differentiate the other one. Differentiate x squared is what? 2x. It's simple. Write the first function, differentiate the second one. Plus, write the second one times differentiate the first one. Minus. In this case now, here, I didn't add dy dx because I didn't differentiate y. I only differentiated x. Good. So it's only when we differentiate y we add dy dx. Now, if I differentiate 5x with respect to x, I'm going to get 5. Equal to, differentiate 3 with respect to s, I'm going to get 0. Because if you differentiate a constant, it is 0. So let's evaluate. X squared times 1 dy dx is simply x squared dy dx. Then plus y times 2x is 2xy minus 5 equal to 0. So my job now is to make dy dx the subject of the formula. That's what I will do now. So I will collect like terms. So this is it. X squared dy dx is equal to 5 will cross and turn to plus. 2xy will cross and turn to minus. So what I will do now is to divide both sides by x squared. X squared cancel x squared. We now have dy dx is equal to 5 minus 2xy all over what? X squared. So this is the derivative of y with respect to x. And this option we can see in option A. 5 minus 2xy over x squared. Option A gives us the correct answer. So let's move to the next question, question 4. Alright, this is question 4. I'm going to use a shortcut to solve it. I want to differentiate 4x plus 2 all to the power of minus 3 with respect to x. And I will find the value of dy dx when x is equal to 1. So the first thing to do is to differentiate that function before we can find the value of the function, that is dy dx, when x is equal to 1. Okay, solution. The function is y equal to 4x plus 2 all to the power of minus 3. Now this is the short way to solve. Although this problem can be solved using the chain rule principle for differentiation, but I will not use that rule since it's going to be a bit longer. Master this. What's dy dx? The y dx says this. Watch carefully. What's the power here? Minus 3. Put it down. Times. What is inside this bracket? 4x plus 2. Differentiate it. It will be 4. Differentiate 4x is 4. Differentiate 2 is 0. So the derivative of 4x plus 2 is actually 4. Times. Now, let's write what is in the bracket again. 4x plus 2. There was the power there, minus 3. I will now subtract 1 from that power. I hope you understand this. First of all, write down the power. Then, what's the derivative of the inner function? Put it down. Let's multiply it now by what is written. Then, the function again, write it back. Then the power, subtract 1. So, if we do this, we are going to obtain minus 3 times 4 is minus 12. In bracket 4x plus 2. Minus 3 minus 1 is minus 4. We have to find the value of dy dx when x is equal to 1. So, when x is equal to 1, what's our dy dx? Anywhere I see x here, I'll put 1. Okay? So, this is minus 12 times 4 times 1 plus 2 raised to the power minus 4. Okay, let's go ahead. This is minus 12. 4 times 1 is 4. Okay, 4 plus 2 is 6. 6 raised to the power minus 4. 6 to the power of minus 4 is equivalent to 1 all over 6 to the power of 4. So what is that now equal to? This is minus 12 times 1 all over 6 to the power of 4 is 1296. Alright, so 12 here is 1, 12 here is 108. So the answer now is minus 1 all over 108. That is the value of dy dx at x equal to 1. And this we can see option B. Question 5. The question says, find the point on the Euclidean plane where the curve y equal to 2x squared minus 2x plus 9 has a gradient of 2. Alright. The point on the Euclidean plane where the curve has a gradient of 2. So for gradient in this case, we are going to use dy dx. Calculus says gradient is dy dx. Okay? So dy dx, which is the gradient, I want to use m now, is, if I differentiate this function, I have obtained the gradient of the curve. Differentiate 2x squared to obtain 4x. That is 2 times 2, 4. 2 minus 1, 1. Differentiate 2x to obtain 2. Differentiate plus 9 to obtain 0. Okay, good. So this is the gradient of the curve. The question says that the gradient is 2. So what it means is that I will set 4x minus 2 to what? 2. So what I will just do to solve for the value of x here. From this, I can say 4x is equal to 2. If this minus 2 crosses, it becomes plus 2. So that 4x is equal to 4. That is 4x is equal to 4, since 2 plus 2 is 4. If I divide both sides by 4, 4 cancel 4. It means that x is equal to 1. Okay, x is equal to 1. But we are looking for what? Point. Point is in the format x, comma, y. But only x I know, which is 1. How do I get y? To get y, I will substitute this value of x into the original function, and a value of y will come out. So the function says y is equal to 2x squared minus 2x plus 9. Anywhere I see x here, I'm going to write 1. Now let's try it. Y is equal to 2x squared minus 2x plus 9. So anywhere I see x, I'll put 1. So at x equal to 1, or when x equal to 1, what's y? 2 times 1 squared minus 2 times 1 plus 9. This is the 1, this is the square, minus 2 times 1 plus 9. Okay, 1 squared is 1, 2 times 1 is 2. 2 times 1 is 2, plus what? 9. 2 minus 2 is 0. 0 plus 9 is 9. So when x is 1, y is 9. Therefore, the coordinate point s, y is equal to 1, 9. This is the point on the Euclidean plane. And this option we can see option D. Question 6. Question 6 says, a water tank is in the shape of a rectangular prism having length 1.5 meters, breadth 60 centimeters, and height 300 millimeters. If 1 liter is equal to 1000 centimeter cube, the capacity of the tank is, okay, let's quickly solve. Now, they give us the length of the tank as 1.5 meters. The breadth is 60 meters, and the height is 300 millimeters. All of them will be brought to the same unit. So if you're using meters for the length, then the breadth and the height must also be meters. Okay, but what we'll do here, let's use centimeters, since they told us that 1 liter is equal to 1000 centimeter cube. So we can easily work with centimeters. Now, I will convert 1.5 meters to centimeters. How many centimeters make 1 meter? It is 100 centimeters that makes 1 meter. So to convert 1.5 meter to centimeter, I'm going to multiply it by what? 100. And that will be equal to 150 centimeters. Okay? The breadth is already 60 centimeters. Good. Now, what is the height? The height is 300 millimeters. Okay? The height is 300 millimeters. But I want to convert this to centimeters. Now, it is 10 millimeters to 1 centimeters. 10 millimeters to 1 centimeters. So to convert this 300 millimeters to centimeters, I will have to divide by 10. Dividing by 10, we produce 30 centimeters. So I have converted all the parameters to the same unit. Good. The question says that the tank is in the shape of a rectangular prism. The capacity of the tank is the same as the volume of the tank. So what is the volume of a rectangular prism? A rectangular prism, the volume is always area of cross-section times height. The cross-section I'm talking about here is the rectangular face. Okay? So the volume is equal to the rectangular face. That's the area of rectangular face. Length times breadth. Length times breadth. Then times the height. Okay, the length is 150 centimeter. The breadth is 60 centimeters. The height is 30 centimeters. So if I multiply this together, what will it produce? 270,000 centimeter cube. Centimeter, centimeter, centimeter. That's centimeter to the power of 3. Okay, now it's simple. This is the volume of the tank in centimeter cube. The options we are given are in liters. So we have to convert this centimeter cube to liters. That's actually the reason why we are given this 1000 centimeter cube as a conversion factor. So what we'll do now is, if 1 liter is 1000 centimeter cube, to get the number of liters in 270,000 centimeter cube, I will divide by 1000. Okay, so it means that 270,000 centimeter cube is equal to 270,000 all over 1000 liters. Converting to liters, you divide by 1000. 0 cancel 0, cancel 0, cancel 0, cancel 0, cancel 0. So what I have now is 270 liters. That means 270,000 centimeter cube is equivalent to 270 liters. And that is the capacity or the volume of the tank. Good. So our answer can be found in option D, 270 liters. This is the next question. In how many ways can the letters of the word minimum be arranged such that all vowels are together? Such that all vowels are together. Okay, this is the word minimum. The vowels are I, and U. So if the vowels must be together, or if the vowels are together, then this is the arrangement. M, N, M, M. All the vowels will take them to be one letter. I, U. It's simple. The I, U will be taken as 1. So instead of having 1, 2, 3, 4, 5, 6, 7 letters, we now have 1, 2, 3, 4, 5. Now, how many letters are here now? 5. Okay, that one itself is 5 factorial. Okay, there are 5 letters. 1, 2, 3, 4, 5. Everything here is 1. Now I can see M repeated 3 times. M, M, M. So I will divide this 5 factorial by 3 factorial. Then this I, I can rearrange it. Yes, I can rearrange them in different ways. So how many ways can I rearrange I, U? First of all, there are 3 letters here. I, U, that's 3. That's 3 factorial. But I is repeated 2 times. So I will divide by 2 factorial. Take note of this. So what is this equal to, first of all? 3 factorial cancel 3 factorial. What I have now is 5 factorial all over 2 factorial. And 5 factorial is 5 times 4 times 3 times 2 times 1. Then divided by what? 2 factorial, which is just 2 times 1. 2 times 1 will cancel 2 times 1. What we have left is 5 times 4, 20, times 3, 60. So there are 60 ways of arranging the letters of the word minimum if all the vowels are together. Alright, this is question 8. Question 8 says, the interior angles of a quadrilateral are x plus 15 degrees, 2x minus 45 degrees, x minus 30 degrees, and x plus 10 degrees. We have to find the value of the greatest exterior angle. Okay. First of all, let's solve for the value of x. This is a quadrilateral, and the sum of interior angles of a quadrilateral is 360 degrees. So it means that x plus 15 plus 2x minus 45 plus x minus 30 plus x plus 10 is 360 degrees. Good. X plus 2x, 3x, plus x 4x plus x 5x 5x. 15 minus 45 is minus 30. Minus 30 minus 30 is minus 60. Minus 60 plus 10 is minus 50. Minus 50 equal to 360 degrees. That is to say, 5x is equal to 360 plus 50 degrees. This is equal to 410 degrees. Divide both sides by 5. 5 cancel 5. That means x is equal to 410 divided by 5. And that is 82 degrees. We have to find the value of the greatest exterior angle. But these are the values of the interior angles of the quadrilateral. X plus 15, 2x minus 45, x minus 30, and x plus 10. So x is 82. 82 plus 15 is 97. 2 times 82 minus 45 is 119. 82 minus 30 is 52. 82 plus 10 is 92. So how do I now get the exterior angle? Because all of these are interior angles. Now take note. Exterior angle plus interior angle is 180 degrees. So I am looking for the one that I will subtract from 180 to give me the biggest exterior angle. Now, if I subtract these values from 180, these are the results respectively. So which one is the greatest? It's 128. So the greatest exterior angle is 128 degrees. That's all. Question 9 says factorize 6 to the power of 2m plus 1 plus 7 times 6 to the power of m minus 5. What I will do now is this. Let me expand the expression. 6 to the power of 2m plus 1 can be written as 6 to the power of 2m times 6 to the power of 1 by the law of indices, so that 2m plus 1 is 2m plus 1 plus 7 times 6 to the power of m minus 5. So I will just say let 6 to the power of m be equal to p, for example. Just watch me. So that 6 to the power of 2m will now be p squared. That is, if I do something like this, 6 to the power of m squared. They are the same. So if this one is p, it means that p squared. Then times 6, that's 6p squared, plus this is p, 7p minus 5. So let me factorize this. I need two numbers that are multiplied to give me 6 times minus 5. That's minus 30. I will add the numbers to give me 7. I want to factorize down quadratic expression. So which two numbers will I multiply to give me minus 30? And I'll add to give me 7. The numbers are 10, that's plus 10, and minus 3. Because 10 times minus 3 is minus 30. 10 plus minus 3 is 7. So this expression will now be 6p squared plus 10p minus 3p minus 5. Okay, thus I use 10p minus 3p to replace 7p. Okay, now I'll factorize by grouping. What's common to this first two is 2p. 2p comes out. 6p squared divided by 2p is 3p. 10p divided by 2p is 5. What's common to this last two is minus 1. Minus 3p divided by minus 1 is 3p. Minus 5 divided by minus 1 is plus 5. So factorizing, we now obtain the bracket are the same. Pick one, 3p plus 5. Then the other terms outside the bracket will be used to form a bracket, 2p minus 1. Now remember, we said let p be equal to what? 6 to the power of m. So I'll replace everything now with that. We now have something like this. 3. In place of p, I'm writing 6 to the power of m. 6 to the power of m plus 5 times 2 P is 6 to the power of m. 6 to the power of m minus 1. I can see my answer in option A. Option A, correct. Alright, thank you for watching this video. I hope you like it. Don't forget to subscribe and don't forget to like. Don't forget to share this video to your friends. I'll see you in the next one.